Good morning, everyone, and welcome to another episode of Math and... One second. Math and silly hats. Look, any port in a storm, okay? Today, I'm going to be going over a topic that about 80% of you guys are ready to learn, and it seems like haven't done yet. So maybe this is avoidance, maybe you just don't know how to do this, maybe you've never seen an algebra tile before. But let's go through it together. So this is the Alex topic, using algebra tiles to determine if two expressions are equivalent. So what's an expression? Well, it's a equation without the equal sign, thus equation, equal sign. So expression is just some terms. Could be variables, could be numbers. And let's look at what each of those look like in algebra tiles. If we don't know what we're doing here, we can look at our explanation. The explanation says we can use algebra tiles like this green one, which represents x, and this blue one, which represents the number 1, to show math expressions. So 2x plus 7. Well, this is obviously two x's, and this isn't numbered as a 7, but if we notice, we count 1, 2, 3, 4, 5, 6, 7 ones. So this expression is just 2 of something. We don't know what x is. It's a variable. That's okay. Plus, well, we can add ones together, because those are like terms, to get 7 ones is equal to 7. Similarly, if we only have 2 ones, we'll have 2 as our constant. So 2 is our constant. And if we have 1, 2, 3, 4, 5, 6, 7 x's, then 7 are our x's. Notice that they've color-coded the constants and variables here. So I, in my last video with CM Toby, recommended you box and circle. Obviously, in Alex, they can't do that. So we've color-coded to recognize that x's and constants are two different types of terms. We can only combine like terms. Now it asks, are these equivalent? Almost always they will not be equivalent because we don't know the value of x. Now, x happened to be equal to 1, then 2 plus 7 will be the same as 7 plus 2, but that's the only case. If x is any other number, these two will not be equivalent. So our answer is no, because x is not the same as 1. It's a variable. Now, this shows us how, much like our problems, we can represent expressions using the algebra tiles. So for 2x plus 7, notice our x's here, if we were to color code them, would be green. So 2x's, we should have 2 green tiles. Here we have 2 green tiles, and here we have 2 green tiles. And then plus 7, if we were to color code that, 7 would be blue. So let me go ahead and make those changes. So we have 2 x's and 7. So we need to have 2 x's, which we have here, and 2 x's, which we have here, but we need to have 7 ones. So here we have 7. Here we have, well, there's 14 there. So when we add these together, 2x plus 7, 2x plus 14, get my x's in there. Well, only one of these represents 2x plus 7, so this would be our first answer. The second way they want us to represent it is 2 plus 7x. Again, x's here in this scenario are green, so we need 7 x's. We have 7 x's here and 7 x's here, but we need to have 2 tools, okay, more tools. We need to have 2 of our, let me just try full screen this. Okay, we lost our tools. We need to have 2 of our constant, and this certainly has 2 of our constant. This has got, well, 14 of our constant. So this would be 7x, apologize, my tools are not working, plus 2. This would be 7x plus 14 ones is 14. So we certainly would have this as our second answer. So let's go back and let's actually do some of these problems together. Another one. Do another one. All right, we want to show 2 plus 6x and 2x plus 6. Do you see the pattern here? It's just transmuting or reversing the two terms. So let's highlight our blue, which is going to be our constants. Our blue, which is our constants. So terms without x are blue. And I'm going to go ahead and mark them all. I see 2 constants over here. I see 1, 2, 3, 4, 5, 6 constants over here. I see 12 constants here. And I see 12 constants here. Now, let's look at our greens, our variables. We want 6x and 2x. 6x and 2x. So I see 2x's here, so 2x. I see 6x's here. I see 2x's here. And I see 6x's here. Sorry, that doesn't fit perfectly. Looking at these expressions, 2 blues plus 6 x's. 6 x's, so beautiful, I know, right? So our expression 2 plus 6x is this one over here. And then 2x plus 6, well, we want 2 greens, and 6 blues, because we have 2 variables, 6 constants. This is our second expression. And are they equivalent? No, because we don't have the same number of variables, same number of constants. I'm going to skip until I see one where we might have an equivalent expression, and I'll show you what that looks like. There we go. All right, so that took a minute. We want to show 4x plus 2 and 2 plus 4x using algebra tiles. All right, so I'm going to go ahead and mark my green for my x's, 4x, 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 4x. Let's represent the green. We have 2 x's here. We have 4 x's here. We have 4 x's here. And we have 2 x's here. And then let's represent our constants, just our numbers. 2, 2, 2, 2. So we have 8 ones here, so 2x plus 8. We have 8 ones here, so 4x plus 8. We have 2 constants here, so 4x plus 2. And we have 4 constants here, so 2x plus 4. So we're looking for 4 x's, 2 constants. 4 x's, 2 constants. This is our first expression. And then 2 constants, 4 x's, 4 constants, 8 constants, 8 constants, 2 constants, 4 x's. So this is our second expression. Now notice that all that happened was we moved the x's and the constants in their positions. We transposed them. The commutative property says that we can move around terms in an addition expression and it's still equivalent. So these are equivalent. All right, let me do one more problem where we may see something a little bit different than what we've seen before. We may see multiple x terms or multiple constant terms.
Another one. Another one. Another one.
This problem is a little bit different than the other ones we've seen in that I see here 2x plus 7, that's normal. We have variable and we have a constant. But in the second expression, 2x plus 7x, both of those terms are variables. So I'm going to do the same color coding I've been doing. I'm going to color code my constants blue, but I only have one constant, this 7. All the other terms are variables. So 2x, 2x, 7x, 2x, 2x, 7x. I've already got green, so let's find my x's. So here we've got 2 x's. Here we've got 7 x's. Here we've got a column of 2 x's and a column of 7 x's because we've got 2 similarly colored columns that all are just x's. Now let's go mark our constants. Here we have 2 constants. Here we have 2 and 7 constants, no x's. And here we have 7 constants. So first we want to find 2 x's, 7 constants. The only one of these that has 2 x's and 7 constants is our fourth expression. So this is 2x plus 7, 2 greens, 7 blues. And then we want to find 2 x's and 7 x's, no constants. So the only one of these expressions that has only variables is this first expression, and it is 2 x's plus 7 x's. Now, are these equivalent? Certainly not, because we do not know that x is equal to 1, so in all other cases, these are not equivalent. Hopefully this has been helpful, and now you're ready to go solve these problems on your own. Have a great day, everybody. Bye-bye!